Hi everyone, welcome back to BeamClue Revit tutorial. So in this session, we're going to learn about creating our own distribution board, the electrical distribution board, and we're going to connect our lighting and socket outlets to our distribution board here. Okay, most likely we'll place the distribution board just after entering the house over here. Yeah. So first of all, as usual, we're going to create a new family of the distribution board. Okay, so go to family over here, search on generate model, open, then we're going to our front elevation and we're going to create a simple extrusion, the rectangle extrusion over here. Let's say it's about 500 times 600 mm height here. Okay, so move it to the center, and then the thickness will be like 150 mm will do. Yeah, so this is a representation of the general shape of our distribution board. Okay, so the next thing is we're going to create our electrical connector for this distribution board here. Okay, just place it over here somewhere on the face. Then select the connector. Then we're going to select the electrical load, system type, go to power balance. Okay, then most likely this house will be supplied to the three-phase supply. Yeah, then voltage will be 400. Okay, then apparent load, we just leave it at the moment. Then load classification, we can select it as a power. Okay, if you don't have anything over here, then you can just create your new one. Okay, then you just fill in as usual. Yeah, then okay, then you have to tell Revit that this is a distribution board. So under the family category, we scroll on here, then this is the electrical equipment and this is a switchboard. Yeah, panel board is for the mechanical panel. Yeah, so this is the switchboard. Then okay, then we are ready to load inside to our project. Okay, so save it for sure. Okay, this is our electrical DB. Save. Okay, load it inside to here. Okay, just place somewhere here. Okay, stick to the wall. Okay, one thing you need to pay attention is you need to reroute your cold water, because you most likely you try to avoid the water supply directly on top of your DB. Yeah, so you can do it later. Okay, we just place it over here first, then make sure it's above the door by using the elevation. Cut section view, go to the view, so move this up to here. Okay, remember to place to reroute your cold water supply. Yeah? So get to the end here. Okay, then the first step is done. This is your electrical distribution board, yeah, with the electrical connector over here. Okay, so the next thing is we're going to connect our electrical equipment, lighting or socket outlet, go to the electrical distribution board. Okay, so we simply click one, then click on power, then you can select the panel, then select this panel, then you basically have connected the lighting to the distribution board. Yeah, we try one again, select this lighting, then select power, or this time you don't need to click on select panel because previously you have done so Revit you automatically select the panel for you, which is this panel, electrical DB. Okay, so it's done, the connection. Okay, so how to verify that? We click on this DB, so we click on create panel schedule, we use the default template. Okay, unfortunately nothing appear here, so then you must know something you have missed out. Okay, so we close this first, then we must go to here. Okay, go to your system or manage. Okay, then you will find your panel schedule template over here. Okay, then you edit a template, edit the switchboard template. Yeah, since it's switchboard, so this is the template just now. Then here are the columns. It's basically it's just like Excel format. Yeah, so the first thing is you click on here, then you can see this section parameters here. You can select your parameters over here, what you need to be shown in your electrical schedule. So the first thing is maybe circuit number. So the next thing is what you need to know. Normally is your name of your load, right? So name, load name, or maybe your load classification, whether it's lighting or power. Then you can select your load classification over here. Then of course the next thing is your cabling, your current usage. Okay, let's say your length of cabling or type of cabling. Okay, go scroll down, wire size, wire type. Okay, maybe wire size. Then we are running out of column. Of course you can insert a column here to the right. Okay, so add another parameters like I want to know the length of the wire, the distance of the load to the panel. Then you need to include the length. Okay, then the current. So apparent current A, apparent current B, apparent current C. So what is real, what is apparent, then is electrical engineering term. Yeah, so if you're not familiar with electrical services and the terms, you might not understand this representing the three-phase current, phase A, phase B, and phase C. Okay, it's apparent power. We have real power and imaginary power. This is the apparent power. Apparent power is equals to real power times the power factor. Yeah. Okay, so we try to click on finish and see what the result will be. Click finish the template. Okay, come back to here. So we edit the panel schedule. Okay, still nothing here because you need to refresh it. Click on change template, then click on OK. So now you can see what has been connected to your panel. So this is the load, this is the parent current. Okay, so Y0, we can go back to your lighting over here, then you can investigate. Okay, then maybe the value is too small to be displayed in the decimal places. Okay, just go to here, then you check on your electrical connector, of course, then you can see that actually this is too small. 60 VA, very small. Yeah. Okay, we just ignore it, then we try our socket outlet. Okay, so here socket outlet, of course the previous section we have missed out the electrical connector. Okay, so we go to edit family, then we place our electrical connector over here, and any place here will do. Then we click on this electrical connector, then select the system type over here, go to power balance. Okay, then obviously this is a single pole socket outlet, then the classification will be power. Okay, then the voltage of course will be 230, then apparent power maybe it's 250. This is just estimation. Power factor you might need to leave it like 1, okay, to avoid confusion, or you can put as 0.9, okay. It's power factor state lagging because it's induction, most likely is inductance load instead of capacitance load. Okay, load it back to our project. Save, of course. Override the existing, then you click on your socket outlet. You can see something like this, means you already have the socket outlet with the connectors. Yeah, so we select a few socket outlets together, then we try to connect the power. Okay, it automatically connected to here. Then we go to the panel again to see, okay, this is the what we have connected here. Okay, so automatically Revit help you to choose the wire size according to the load calculation. Okay, so you can know the wire size, you can know the length, and you can know the ampere. Okay, let's say if I want to choose this to move up, move down, this is a way of present. Actually, you can move up, move down, means it's fall under another circuit branch already. Okay, so in the table you might didn't show anything, but if you imagine it as a schematic diagram, it will show that it's actually from the other feeder. Okay, which is another outgoing, under another breaker. So this is the breaker number actually. So you can switch the phase, switch to phase B, switch to phase C. So a good design is we have all the loads in a balanced way. Yeah, so means that phase A have the total load same as phase B, same as phase C. Okay, so no one side, no design on one side. Okay, not heavy loaded on one side. Heavy loaded on one side, one phase, means it will trip. Yeah, so and shorten the lifespan of your breaker. Okay, so that's all. Come back to here. So this is the next thing is when you click on here, you can realize that this is a distribution system over here. So different countries have their own different distribution system. So under us, under Malaysia, this is the star delta system, 3-phase 4-wire, and the single phase will be 230, and the 3-phase will be 400 volts. Okay, so how do we configure that? We can go to manage over here, come back to here, MEP setting. You can go to the electrical setting here. Here you can set your voltage definition. So let's say you have some weird voltage distribution, let's say, or you have blank over here. You can add something like a new voltage name. This is your name, yeah. So let's say I have a 200 volt name. Okay, so the value will be 200. Okay, so minimum. So what is minimum? What's maximum? So under a regulation of your electrical distributor, they need to comply certain variation under the steady stage voltage regulation limits. So for our country, like 400 and 230 volts, it will have a plus and minus 10% tolerance of the variation. Okay, so here, let's say if it's minimum, let's say it's minus 10%, means it's minus 20 volt, which is minimum will be 180. So the maximum will be 220. Okay, so this is for example. Of course, in my country is 230. Okay, so next thing, this is a single phase, so you must have a 3-phase. Let's say your 3-phase will be let's say 415. So since I have the same name over here, I can't override it. So the value is 415. So the minimum of 415 minus 10% will be 415 minus 10% will be 415 minus 4.15. Yeah, so let's say it's 410. Okay, then this is a 419. Okay, that's all. Then you have assigned a new voltage definition. Then in the distribution system, okay, this is the distribution system that Revit automatically assign me, or automatically assign my switchboard to be. Okay, because I assign my voltage of the electrical connector. Yeah, this electrical connector. Yeah, just now I've keyed in 400 volts under my electrical connector. So if I key in something like a 500 volt, it most likely can't detect which category I fall under. Okay, so I go back to here, MEP setting, electrical setting. Okay, now if I have a 500 volt distribution system and 500 volt connector, okay, you need to have a distribution system. Okay, so let's say this is your name, electrical distribution system. So what is the name? Normally is a star delta type. Okay, this is under our country, star delta. Star delta is just now I have created 200, right? Then 400, 415. Y arrangement is Y is this arrangement, Y star delta, or the star is Y. Yeah, so 3-phase, of course. Then configuration star 4-wire, 3-phase 4-wire means we have phase number A, B, C, or red, yellow, blue, and one neutral. Okay, then line to line voltage normally is 415. This is the 3-phase voltage. Yeah? Line to ground voltage, which is the single phase voltage. Okay, so how do we come to this figure? You need a bit of electrical engineering calculation. It's something like this here. Okay, so that one, if you are not electrical engineer, then you just forget about it. Okay, so click OK. Then you will have your electrical distribution system over here. Okay, so since I already have here, then I no need to crack my head to create one. Okay, if you don't have, then you need to go through the process just now I've shown you. Okay, so how about the showing my cable? Okay, so let's say this one, you can show the arc cable over here. Just click on here. This is your cabling, and you just click on here, arc wire. Okay, if this one is connected to here, this one also, create power, then select your dB. If you have more than 1 dB, it will be listed down here. Then you can select your dB through the list here, or just simply click on this select panel to select your dB. Okay, so this is a way of showing your cable. Click on arc wire, you're showing your cable. If you accidentally delete this, it also doesn't matter. Okay, because the circuit is already formed. Yeah, you can click it again, then you will form back your wire. Okay, this is just a graphical representation. It doesn't mean anything. Yeah, so it's shown that your wire is, your electricals come from this dB. Yeah, you will point to the location of the dB automatically. Okay, so go back to your electrical dB again, and it will be automatically updated again according to the load that you assign. Okay, then how to enhance the switchboard diagram here? Then it's just you need to go back to your manage. Here, panel schedule, edit the template, then edit your switchboard again, open it, then you need to modify and add more information from here. Then you load it back to your project, then you will have a fine-tuned version that suit your company of your projects. Okay, so I guess that's all for this session. Thanks for joining.